Okay, there we go. So I'm going to be recording the sessions and uploading them to YouTube for you guys to look at later if you so choose, or if you miss a session, then you can catch up on what was said. Basically, it's for you guys to use how you see fit. And I'm going to try and upload them right after I finish teaching. So today, what we're going to do is we're going to review this new rule that you guys learned, conditional introduction, and go over any of the problems you guys may have had with homework in trying to do some of these exercises. And then after that, after we do a little bit of a review of conditional introduction, I'm going to teach you guys a new assumption rule, negation introduction, which is where the magic happens in logic. That's when we get to do really fun stuff. Okay, so before we start things off with conditional introduction, did anyone have any questions from the exercises or homework, or just questions in general?
I did, yeah.
Awesome.
So I saw in the textbook that you could do like subderivations in a subderivation, which we didn't really go over. So like, is that possible?
Definitely, yeah. And I think one of the exercises I got set up today will show you that you can do you can do an infinite amount of subderivations in a derivation. So you can make assumptions in assumptions without closing off that assumption line. And each assumption you add adds a new subderivation. So it would look something like this. So if I were to do that, like let's say this is line 4 in some derivation, I could assume, whoa. I could assume, no, why is it doing that? Oh, whatever. FA. And then if on line 5, I might make another assumption, GB, and it would start a new line, new assumption line. And these would go until the assumption's been discharged. And for the more complex derivations, like the 8 or 9 out of 10 difficulty ones, this is definitely something you'll have to do. Maybe assume a complex well-formed formula. Yeah.
And so it works the same way, like regular derivations where like you can't go into the first derivation and pull something out of the third one, right?
Yes.
Like it closes off.
Right.
Okay.
So I'm going to use red pen here. So this first derivation, anything on that line is accessible on this one, but green, or I should use different color, but anything here is not accessible after it's been closed off. So the reverse of how those colors are normally used to indicate, you know, permissible and impermissible, anything in the far right line is not in the scope of the far left line, while the far left line is bigger in scope and thus can be used in the far right line.
Okay, thank you.
Okay. Okay, any other questions you guys had? Okay. So here's our rule for conditional introduction for the schema. I'm going to put that beside this derivation we're about to use. All right, so we've got a derivation here. It's got one premise, and it's got a conclusion. Let's see if we can get to that conclusion. So the conclusion has, as its main connective, a conditional. And doing our working backwards strategizing, thinking about what the last rule is going to be for this, we're likely going to have to introduce that conditional, which means the last rule is going to be conditional introduction. So if the last rule is going to be conditional introduction, and we're writing out above that what we'll need in order to get that conditional, we can use this schema as a guide. So what you want to do, you want to visualize this as filling in the sort of requirements that you will need. So since HA is the P or the antecedent to this, you can start with that as an assumption. So a really common strategizing issue that people come across is making the wrong sort of assumptions. You don't want to think of assumptions as something you're just inventing. They're what you have to put down in order to get the well-formed formula you want. So the thing that you want there at the bottom. Okay. So knowing that we have to get FA now in order to complete this derivation, how are we going to get there? Can anyone tell me what line number 3 will look like?
Introducing a disjunction.
Okay, yeah. Why do you say that, Maddie?
Because we need the antecedent for the premises to get FA.
Mm-hmm. So FA is in premise 1 there, and it's what we need in order to complete the subderivation. So we can, our next goal is figuring out how to extract that. Okay. So one thing we can do is make the antecedent to that conditional in the premise. Citing line 2. And then, nope, line 4 should not be there. Arrow elimination. My arrow is extremely terrible. And then 3 and 1. And then this is line 5. And we've finished our little subderivation, now the big derivation. Okay, any questions about how we did that?
So the subderivation is just getting the antecedent and the consequent, right? Like you don't cite line 5, like the actual introduction, as under the subderivation.
Yeah.
I guess. Okay.
So let me see if I can figure out how to do a pointer in this mode. No. Okay. So once we get to here, the fifth line, when you're actually using the rule, you just cite the lines that came before it. So once you have the antecedent and the consequent in inside the scope of the line of the assumption line, you can close off that rule and introduce the conditional. And this follows from the semantics for the conditional symbol. So if you remember, in derivations, you can sort of think of derivations, each step in a derivation is something we can assume to be true if we assume the premises are true. So if we're assuming HA is true and we get to FA using the rules of inference, which all are truth preserving. They're truth preserving steps that take us from things we know we're assuming to be true to other things we can assume to be true given that. Well, if we assume something and use the rules of inference to get something else, we know that there is a conditional relation between those two things. In fact, any line has a conditional relation to the line before it in the derivation. Okay, hopefully that wasn't making things more confusing, but yeah. If some of you guys are being helped by thinking of this from a semantic perspective, thinking it that way will help. All right, what I'm gonna try now is I'm gonna get you guys to do, I believe this is a homework question. So I'm gonna get you guys to try a homework question right now that we'll take up together. Do you guys have materials with you to be able to do a derivation? Okay. If not, I'll give you guys a couple of minutes to get some materials. So this will help. We'll do this together, and if you guys are having trouble figuring it out, then I can help you directly right here. So get your materials together. I'm going to write this out. Yeah. So how many of you guys have had your other professors that were sort of not telling you what was happening speak up again or tell you what's happening? Does anyone still have classes where they haven't heard from their professor and don't know what's going on? No? Okay, that's good.
I had one email me like 30 minutes before class started saying like, oh yeah, we're gonna be on Blackboard Collab Ultra. I was like, oh, okay.
What's Blackboard Collab Ultra like to use? Is it similar to Zoom?
Yeah, it's pretty similar, but it's kind of easier because like they have a whiteboard thing that everyone can write on, like what you
Oh,
were
yeah.
trying to do, and then you can like raise your hand in the class and stuff.
Huh. I might give that a try then.
Hmm.
Cool. Nice. Yeah. Okay. Is anyone finished with this derivation? Okay. Awesome. All right, let's go. Did anyone have any questions about it?
I guess my question would be that it looks like there's, I guess, is there two different ways you could go about it? Like you use the same rules, but as far as the order of things.
Hmm. Yes, definitely. So it all depends on what order you break down the premise in. And there's a couple things you can do. And I guess I'll do the non-working backwards way. So if you're working backwards, there's one way this is going to look. And that's where the whole derivation is in an assumption rule, or in the scope of some assumption. But we can sort of progress with this derivation without making an assumption at all at first. And so if we just thought of our strategizing as breaking this down as far as we can get before using other rules, then this is what it's going to look like. Since we have a conjunction gluing together this first premise, we know that we can just break that apart and get oops. All right. So this is about as far as we can get before making any assumptions. All right. One thing we can remember, and if you think of the biconditional semantically and what it means, is there's a truth equivalence. So the conclusion here at the bottom is asserting that if you have negation fk, if that's assumed, then you have this conjunction, JA conjunct HDD. And if you notice on line 2 and 3, we've got a negation fk linked as a biconditional to both those atomics. So it's sort of intuitive what we're going to be doing next. We're going to be assuming negation fk and getting that conjunct. So what Reese was referring to is that we could have started that assumption right at the beginning of the derivation, and it wouldn't make a difference. So anything that occurs before the scope of that assumption is still usable in our rules of inference. So I'll show you what we'll be doing now. We can use biconditional elimination, 4 and 2. And now we can get that conjunct we need in order to discharge this assumption and get our conclusion. So it's important to remember that JA and HDD need to be in the specific order in order to use it as part of the rule of the conditional introduction.
Wait, you said HDD and JA have to be in that order?
Yeah. So not line 5 and 6 though, just on line 7.
Okay, thanks.
There, it has to be that exact one.
So basically the point of the whole subderivation is to get the antecedent and the consequent.
Yes.
Okay.
Yeah. So the first line should be the antecedent, and the last line should be the consequent of the conditional you're trying to get.
Okay. Thank you.
Yeah.
So if we had that like the HDD and then the biconditional was a conditional, like on, I guess, line 2, would you be able to assume HDD to get FK, and then it would still be fine to like continue like inside that subderivation, or does that first line always have to be the antecedent?
It has to be the antecedent. So if we assumed HDD and got negation FK, that would give us this, we would get this conditional, which as part of a strategy for getting to that conclusion wouldn't help us. Yeah. So I just finished baking some bread before this class started, and I need to eat another bite. Okay, cool. Did anyone have trouble with this question?
How do you know when to like stop the assumption? 'Cause I stopped, and when I did, I stopped the assumption at 6.
Okay. So you stopped the assumption when you got J. Sorry if that was really gross. I don't know how much of my eating actually carries over the microphone. All right, I just realized that was bad. So if you stopped at JA, that would give you the following. I mean, you could do that, but the thing that you would get according to this rule would be negation FK conditional JA, which also wouldn't really help you, but it would be a valid move. So what we're getting, what these assumption rules allow you to do is a lot more moves, right? You can derive a lot more things, but strategically, they're not going to be what you would want to do in order to get to the conclusion. Does that make sense, Vivian?
Yeah, I think so.
Okay, cool. All right. Do you guys want to do one more conditional introduction, or do you want to learn the new rule now? New rule? Okay. So this is my favorite rule because it's actually a rule that is sort of philosophically contentious to, in some ways. And it's one that's used very commonly in arguments. So negation introduction is the second and last assumption rule we'll be covering. And once we have this rule, we have all the rules of inference at our fingertips. So the schema for negation introduction lets you take, assume a well-formed formula, and then if you can derive any contradiction within the scope of that assumption, you can derive the negated version of that thing that you assumed. What this means in practice is that you can assume anything, and as long as you can get a contradiction, you can introduce that thing into your derivation as a negated version. In classic philosophy and argumentation, back in the day, this is called reductio ad absurdum, because what you're doing is you're showing that some assumption reduces to an absurdity, a contradiction, which can't exist, right? Contradictions, asserting that something is both the case and not the case is not ever going to be true, right? So it's such an absurdity that if you assume something and get a contradiction from it, it shows that that thing is also false, or, you know, can be thrown away. A lot of philosophical arguments go this way. So starting from a bunch of assumptions, you get a contradiction, which shows that your whole argument was sort of not worthwhile from the beginning. Okay. So I'm just going to do one right now, a quick derivation using this new rule to show you guys how it works. I'm going to put the schema beside the derivation so it lines up sort of well with what we're doing. All right. In this derivation, I've got a premise. It's a conditional. And then I've got a negation as the conclusion. Before this rule, we would be sort of hosed here. We wouldn't be able to complete it. Now with this rule, what we can do is, since we know that we need this, that the main connective here is a negation, we can introduce a negation. And what do we need to assume? If we are trying to get negated FA, we need to assume FA. All right. Once we have FA, we can eliminate that conditional and get negated FA. Some people might be tempted to say, aha, the derivation is over now because we got negated FA. But one important thing to keep in mind is that if you have your conclusion, but it's in the scope of an assumption, it doesn't count as finishing the derivation. So the conclusion has to be outside of the scope of the assumption. So this does not count as finishing the derivation yet. To finish it, we have to get this contradiction using conjunction introduction on line 2 and 3. And that counts as the Q conjunction key, negation Q for finishing our derivation. And since we have that requirement met, we finish our derivation. Okay. Any questions about this?
So would it be for line 4, are you citing lines 1, 2, and 3 or just 2 and 3? Oh, never mind.
Yeah, just 2 and 3. So that's the I. Yeah, I had to squish things down there.
Sorry.
Yeah. So it's not always going to work out that the contradiction, this thing, is going to be the same as P, right? It just so happened in this derivation, that's how it went.
I have a question.
Yes, James.
So is Q just FA, not negation FA? So like the negation doesn't transfer over to the like. So like Q and P are both just FA.
Mm-hmm.
Okay.
Yeah.
Okay, that makes sense.
Yeah.
When you're citing things from the assumptions, do you always have to cite like the whole, like every line of the assumption? So like for line number 5, you can't just cite line 4, you have to cite lines 2 to 4.
Yeah. So when you're citing using assumption rules, the convention is to cite the whole range of lines that the assumption line goes through.
Okay.
Cool.
Why wouldn't you use a conjunction elimination after line 4 just to get the negated FA?
Aha. So that's a great question, because first of all, so you're saying for line 5, we don't need to use that rule. We can just use conjunction elimination, right? Okay. So there's actually two problems with that. So line 5. Is that what you were thinking of, Maddie?
Yeah.
Okay, so the problem here is that if we can't stop the assumption line without discharging that assumption. So since we didn't do the negation introduction rule, the assumption line keeps going. And since it's something derived in the assumption line, it can't count as our conclusion. So that would be one problem. The other problem with doing this according to the rules is that if we didn't draw our assumption line, which would be against the rules, we'd be breaking the rules already. We'd break another rule where you're using a rule of inference outside of an assumption line on something inside of the assumption line, because this now is no longer in the scope of this thing. Okay. But yeah, that's an important question. It's has to deal with just this new thing we've added, the assumption line.
So you basically you can't just start assuming things, you have to do it with an intention.
Yeah, because in order to get rid of the assumption and solve the derivation, you need to get specific things. So with negation introduction, it's a contradiction. And with conditional introduction, it's really anything, but you're going to be introducing that conditional in order to discharge the assumption. You can't just get rid of the assumption, however you please. Yeah, so the most helpful way to use these assumption rules is to think backwards. Because if you're thinking forwards, you can assume anything, right? And that's, as a strategy, not going to be as easy to think through as starting off with looking at the conclusion for this question, for instance, and being like, okay, I've got a negation here. Let's try out a negation introduction subderivation here and see if I can get that negation added. It's not always going to work out that way, because with the negation introduction, we've added a way for us to add anything we want to derivation. And the negation might not always be, the negation introduction might not straightforwardly get us what we want, but it might help us get us something else that we need to get there. That's going to be clearer in the more difficult derivations. Okay. All right, we've got some time. So I want to do a derivation that uses both these rules now. So conditional introduction and negation introduction. And this will be a true test. I'll give you guys 5 minutes to tackle this one, and then we'll do it together. All right. How is everyone doing with this question? No. Does anyone feel like they have it? No? Vivian's maybe. Yeah, well, before I got on here, I was baking bread and playing the new Animal Crossing, trying to trying to decorate my new Animal Crossing home. So that's my COVID life basically these days. I imagine a lot of you guys have similar similar COVID lives. Okay. I think this is what I'll do with this question. I think it'd be great if we had more time to just unpack it and go through it really slowly, which we don't have right now. So it's actually in the textbook as a homework exercise, and I think it'll be good to like spend 15 minutes just doing this together. So if you guys want to try this at home as sort of a challenge question, it'll help you sharpen your skills for doing the homework questions due on Friday. And that'll be so. I'll just like quickly go over the homework again, or what we're doing for it, and then we'll end our session today. So just a reminder that the homework's due on Blackboard under the assignments tab. So I'm guessing most of you guys are just going to be using paper to do it and then take a picture with your cell phone. Is everyone pretty comfortable with, is anyone uncomfortable with that or not sure how to do it? So if any of you who want to email me the thing instead of uploading it onto Blackboard, that's fine. But Blackboard's going to be the main way that I take up your homework and then grade it. So just a reminder, it's only the underlined questions. You should only be uploading, I think, 4 or 5 questions. And then that'll be graded similar to how your quizzes are graded, instead of 20. And I'll try and get those back to you as soon as possible, so you have a rough idea of how the grade's going in the class. Yeah, and also a reminder, if you guys ever want to do just a one-on-one Zoom session, I'm always open to that. I'm just sitting here playing Animal Crossing and baking bread and trying to find other hobbies to fill up my time. So I enjoy doing logic, so don't feel like you're bothering me. Okay, yeah, so that's it. I'll put this on YouTube so you guys can check it out later, and have a great rest of your week.